Okay, children, so we are discussing 10.10 activity, children. 10.10 activity, light research. Okay, coming to the page number, it is 173. Okay, children, this is a glass lab experiment. Glass lab experiment. Please see here, children, very, very important. This is. In glass lab experiment, what you will do, children, you will take a plain paper. You'll take a plain paper, and on this you will put a glass slab. Now what you will do, children, here you will draw a normal. You will draw angle of incidence. Anything angle of incidence should be between, remember, 30 to 60 degrees only, not less, not more. Okay, children, start with 30. Put here two pins, children. Two pins should be at a distance of 2 to 5 centimeters distance only. And the two pins you observe from this position, other side of the glass slab. From the other side of glass slab, you see the two pins. Wherever you see the two pins, put two dots. Join those lines. Draw normal. Connect this both. Okay, children, this is called incident ray. This is called emergent ray. This is refraction 1. This is refraction 2. This is angle of incidence. This is angle of emergence. Okay, on doing this experiment, you will come to know that angle of incidence and angle of emergence are equal. Why? Because this ray and this ray will be parallel. This ray and this ray will be parallel. So angle of incidence will be equal to angle of emergence. Do for 30, do for 35, do for 40, do for 45, do for 50, do for 55, do for 60. Angle of incidence you should find out, angle of refraction, angle of emergence. Take 30, take 40, take 50, take 60 degrees, children. Okay, compulsory this also will be 30, at least near to 30, 40, 50, 60. But this will be, children, this is rarer, this is denser. Rarer to denser, it comes towards the normal, so angle will decrease. If it is 20, minimum 10 degrees, it will decrease. Okay, here it will be 30, here it will be 40, here it will be 50. This will be your calculations when you do. This is how we are going to do the activity, children. This is how we are going to do the activity. Okay, and suppose if this glass slab was not there, light ray would have gone straight, no, children. But because of glass slab, light ray is shifting by this much displacement. What is that is called, children? What is this displacement is called? The displacement is called as lateral displacement. It is called as lateral displacement. What is lateral displacement, children? It is the distance between incident ray extended forward and emergent ray. It is the distance between incident ray extended forward and emergent ray. It is the distance between, please see here, children. It is the distance between incident ray extended forward and emergent ray. It is the distance between incident ray extended forward and emergent ray. It is the distance between incident ray extended forward and emergent ray. What factors lateral displacement depends? The lateral displacement depends upon following factors. First one, thickness of glass slab. Very, very important in board exam also they asked. Thickness of glass slab. Number two, refractive index of glass slab. Refractive index of glass slab. Number three, angle of incidence, how much angle you are taking. Lateral displacement depends upon thickness of the glass slab. Thickness will be there, no, children. Thickness of the glass slab, okay, and thickness of the glass slab, and refractive index, the material of the prism, I mean to say, sorry, glass slab, and angle of incidence, how much angle are you taking, that also it depends, children. On these three factors, the glass prism lateral displacement depends, children. So what are the factors on which lateral displacement depends? Thickness, refractive index, angle of incidence. Thickness, refractive index, angle of incidence. What is lateral displacement? It is the distance between incident ray extended forward and emergent ray. Distance between incident ray extended forward and emergent ray is called lateral displacement. How I am conducting, how we are doing the activity is also very, very important, children. In the exam also, if they ask, you should be in a position to draw. Those who need not understand, once again I am drawing and showing children orally. Please see here, children. Incident ray, rarer to denser towards the normal, density rarer away from the normal. This angle and this angle will be equal, and this also will be equal. Remember, children. This is angle of incidence. This is angle of emergence. This is refraction 1. This is refraction 2. Okay, children. What is the conclusion? What is the conclusion in glass slab activity? To show that, what is the aim? What is the aim? To show that angle of incidence is equal to angle of emergence in glass slab. To show that angle of incidence is equal to angle of emergence in glass slab. Diagram is very important. Anyone have any doubts on this question, children? You can ask me in this